Hello, welcome. I would like to go over your Jamboard so you have the correct answers before, um, so you can review for your test. And so I will go through these problems. It says in here that in cattle, red is incompletely dominant with white. And so the name of an individual that has one allele for red and one allele for white is called roan. It's a mixed color that results from incomplete dominance. So this question is asking, what are the results if a white male mates with a roan female? So our Punnett square is going to be the white male, WW, mating with a roan female, RW. And so we get RW, RW, WW, and WW. So that answer would be 50% white, whoops, not white, not what, but white, that says white, and 50% roan. So remember, incomplete dominance is when you get a mixture of colors, not spots. So roan is kind of a mixture of the red and white. In cows, it's not truly pink, but it's more kind of like the background here on the wall, that kind of an orangey looking color. The next one talks about crocus flowers. Crocus flowers come up in the spring, and they can be white or purple or white and purple striped. So it says in crocuses, white and purple are codominant, meaning they both show up. So co means that they are both present in their pure form. So you're going to get white and red white and purple mixed. So what are the possible results from the cross-pollination of a striped crocus with a white crocus? So the striped one has one white allele and one purple allele. And the white flower has two white alleles. Because white and purple together in incomplete dominance, in codominance, show up as a striped flower. So we would get white in this box, striped in this box, white, and striped. So you would get 50% white, 50% striped. Okay. The next one is on blood types. So a mother is blood type AB, and the father is heterozygous for blood type A. So remember with blood types, if you have the A phenotype, you could be AA or AO. So if you are AO, you are heterozygous. So in this case, the father is heterozygous. So mother, AB, father, AO, the hetero. So they have a chance of being AA, possibility, or AB, or AO, or BO, which you all know is my favorite blood type, stinky blood type. So what blood types can their children have? These two would result in A blood type. This would result in an AB, and this would result in a B. Okay, so 50% A type, 25% AB, and 25% chance of B. These are the phenotypes. These are the genotypes. Okay, so just a review of that. So the next one on pedigrees. I should probably move myself here so you can see it. Pedigrees, we're looking at a hitchhiker's thumb, and we're wondering if it's dominant or recessive. So remember, a shaded in individual has the trait. So number 1 has the trait and number 3 has the trait. Now the way you read this is generation 1 across, this is generation 2 across, this is generation 3 across, and this is generation 4 across. So these would be the kids, these would be the parents, these would be the grandparents, these would be the great-grandparents. So we can figure out that this is a recessive trait. And the reason why is because if it were dominant, it would show up in a generation before this one. So that's the answer for number 7. If you have the dominant allele, you will have the dominant trait. So there's no way that this could be dominant. How are individuals 3-1? The way you read this is the first person, this is column 3, this is number 1, and this is 3-2. And because there's a line right here between them, you know that they are married or have had children. So those are spouses. How would you name the second individual that have a hitchhiker's thumb? So this person has a hitchhiker's thumb. Is it male or is it female? Remember, this is a male. If it's an X, that's the symbol. And this is a female. So circles are females, and the fact that she has this trait is how we would name this. She's an affected female that has the hitchhiker's thumb. Name the 2 individuals that were carriers. Carriers means that they are heterozygous. And so we're looking at these 2 individuals because if this son were to get an allele, so let's give this hitchhiker's thumb letters. So we know that I'm using H's because we usually use the letter of the trait. So we're saying that this person, this son, is homozygous recessive. This daughter is homozygous recessive. So that means this allele came to this son, and that means that that was the mother. So the mother gave this allele. The father had to have given this allele. So we know that person 3-1, or this one, number 1, and number 2 are married. I wonder if this question meant that we were looking over here, but in general, you do the whole line, and it doesn't really matter because they're both married as well. All right, so is it possible for individual 4-2, so maybe they are looking at this one, sorry, to be a carrier? Entirely possible because it's a recessive trait. So yes, because they received 1, can I change the color? They received 1 allele that was a capital H. She could be big H, or little h, little h. Okay? So the last one doesn't have any words on it. So I'm not sure if that was just set up. Mr. Olson shared this with us, so I don't know if that was set up just so we could practice something if you had a question. But I wanted to tape this just so you have the information if you were not present when I went over it. So that's it.